Okay, so this is kind of an introduction to Unit 7 because we're going to be talking about shapes, mostly on the coordinate plane, but we will look at some similar figures like these. It's pretty much kind of like proportions like we talked about before and like you talked about in 7th grade. So similar figures, two figures are similar if they have the same shape. So the same shape, but not necessarily the same size. If the figures are similar, then their corresponding angles are congruent. Congruent means same size. And the measures of their corresponding sides are proportional. Okay, so proportional just means they can scale up or scale down to each other, but they're not going to be the same. Okay, but the angles, however, will be the same. Use the symbol, this little squiggly, for similarity. So if you see that, know that it means this is similar to this. And use this symbol, like the angle, to represent a specific angle measure. Example, angle A. And congruent, same size and shape. So let's look at example 1. Triangle ABC is similar to triangle DEF. What do you know about the corresponding angles and sides? So a couple of ways to do this. When they give you these little rings on the angles, I like to number them. So like there's 1 ring here, 2 here, 3 here, 1, 2, 3. So then it's a little bit easier to see that A and B, that's angle 1 and 2. And so what's angle 2 over here? Well, it's D and E. Okay, so that's why these are proportional to each other. A and B was 1 and 2 on the smaller triangle. D and E was 1 and 2 on the bigger triangle. And so the measure of angle A to B is 4, and D to E is 6. Okay, so then we look at B to C. B to C, right here is 6. And then E to F is 9. And then A to C, we've got 8. And D to F is 12. So the corresponding angles are congruent and the corresponding sides are proportional. So if we wanted to, we could reduce those all down or divide them. And so if you divide all those fractions, or if you reduce them down, if you divide them, you get 0.67 on each. If you were to reduce it, it would be 2/3 on each one. So example 2, a little bit different. KLMN is similar to rectangle PQRS. Determine the missing side measure, and then to determine the scale factor from KLMN to PQRS. And so when they give us these, when they just kind of list them off, I like to number them also. So KLMN 1, 2, 3, 4 is similar to PQRS. So you know that K and P are the same. That's your angle 1. L and Q are the same. M and R are the same, and S and N are the same. And with these, when they're set up the same way, it's not really necessary. It's when, like this one, when they're set up a little bit different and they're turned, that'll help. Okay, so let's figure out the scale factor. So let's just look at KL, P to Q. So K to L, or angle 1 to 2 is 5. P to Q is what we're looking for. So I want to set up another side length so I can find that X value. And the only other ones I have measures for are 1 and 2, or K to N. So that's 4. And I've got P to S, or 1 to 4 again, which is 3. And so we can do just like we would solving a regular proportion, cross multiply and divide. So 5 times 3 is 15, divided by 4 is 3.75. So my missing side length over here is 3.75. And to find your scale factor, we'll talk about this in the next set of notes that we do, but the scale factor to find it is you take your new side length and divide it by your old side length. So say we take 3 and divide it by 4. That's our new, and this is our old. So new divided by old. So 3/4, which is where they get this. A length of polygon PQRS is 3/4 times as long as corresponding length on polygon KLMN. So exercises down at the bottom. Number 1, the polygons are shown. Polygons shown are similar. Sorry. What do you know about the corresponding angles and sides? Another thing I need to talk about. All of your angles remain the same. So whether your image gets bigger or smaller, your angles are going to be the same. Those are all right angles. So nothing changes there. So on this first exercise, what do you know about the corresponding angles? Again, the angles are going to be the same, but we want to figure out the sides. So they label off our corners. So A, B, C, D, just like you are saying the alphabet. And that's how I numbered them, 1, 2, 3, 4. And so I'm going to do the same thing on this one. So W, X, Y, Z. So 1, 2, 3, 4. And that's just so I know which side lengths are proportional to the next. So I see 1 to 2, angle 2 to 1, and 1 to 2 here. So that's how I'm going to set up my first proportion. So angles 1 to 2 are A to B is 12, and 1 to 2 over here, or W to X, is 9.6. Okay, and so then I want to figure out what my missing length is. So from 1 to 4, I got 5. 1 to 4 over here is 4. And so what do you know about the corresponding angles and sides? So the angles are the same, and these are proportional. So I guess we're just looking for, there's not a missing measure on this one, so we're looking for the scale factor probably. So if we take our new and divide it by our old, I'm going to use my new side of 4 and my old side of 5. So my new one is 4/5 the size of my old one. And the angles are going to be the same. They started out as right angles, and now they're still right angles after we change it. Number 2, the triangles below are similar. Determine the missing measure. Okay, this makes a little bit more sense. So they don't give you letters on these one. They don't label them, but I'm going to label those angles because they kind of do that for you at least. They give you those rings. So this is angle 1 because there's just one ring. 2, 2 rings. 3, 3 rings. Same thing here, 1, 2, and 3. So we want to set up a proportion to figure out what the missing side length is. So from 1 to 2, angle 1 to 2 is 6. Angle 1 to 2 on my smaller triangle is 4. And I want to find the missing side length. So that means I have to look at the corresponding side for the missing one, which is between 2 and 3. And since I'm going from big to small, I've got 15 over here and X over here. And so cross multiply and divide. So 15 times 4 is 60, divided by 6 is 10. So my missing side length right here is 10. Number 3, the polygons shown are similar. Again, what do you know about the corresponding angles and sides? They are, so the angles are not going to change. The angles are going to stay the same, even though this triangle might be a different size than this triangle. The angles remain the same. And the sides, let's look for the scale factor. So we'll go new to old, I guess. And so if this one is our new, this one is our old. So new, we'll say 5. I'm just going to use this side length. So that means I'm going to use this side length on the other one. 5 over 5.1. So 5 divided by 5.1. So 0.98 is your scale factor. And then on number 4, the triangles below are similar. Determine the missing measure. Again, they just give you those rings. Well, they give you rings and they give you letters. But I'm going to go ahead and label them 1, 2, 3, 1, 2, and 3. And so we want to find the missing measure. And so that's between 1 and 2. So I want to find 1 and 2 on my bigger one. So to set my proportion, I'm going small triangle to big. So small is X. The big 1 and 2 is 12. And then I need to pick one more side. So I'm going to pick the measure between 1 and 3 for both, because they both have a label there. So on my small triangle, my measure between angle 1 and angle 3 is 10. My measure between angle 1 and angle 3 on the big triangle is 18. And then I'm going to cross multiply and divide. So 12 times 10 divided by 18. And I get 6.66. Repeating, I'm going to put 6.67.